Alright, so let's do a second question. This one is 10x minus 5y greater than 0. So we are going to approach this question pretty much the same manner as we did for the last question. And again, if you find it annoyed by the inequality sign, simply change that to the equal sign. If you're okay with the inequality signs, then don't bother, just keep going, right? So once again, we are trying to isolate y, express y in terms of other variables, because our graphing calculator can only do y here, right? So we have 10x minus 5y equals to 0, and then 10x, so you add 5y to each side, equals to 5y, and then divide both sides by 5. Okay, nice and easy. So that means on the left hand side you have 2x, on the right hand side you have y. So let's graph this. Y equals to 2x, y equals to 2x, graph. Okay, so once again, you can take advantage of the graphing calculator second graph to get the table of values. Just plot a few good points. Okay, so we have 0, 0, and then 1 and 2, and then -1 and -2. So we can make a good graph. Well, try to use a ruler. Sorry, this doesn't look like a straight line at all. Anyway, so we have something like that. Now let's go back to the question here, because we are not talking about equal sign here. We are actually talking about greater than, so replace all the equal sign with greater than. Okay, greater than, and greater than. I don't know if you guys can make sense of this notation or not. Actually, this means y is less than 2x. Of course, you can say 2x is greater than y, but if you recall what I mentioned for the last question, we always look at this with respect to y. So if you want, you may want to flip this around, of course changing the sign. So you can write that as y is less than 2x. Have a look. Okay, so second part is shade the area, the solution area. But before we do that, let's get this straight. Because if you look at this graph, we have less than. We don't have any equal components. So what do we need to do is draw a dotted line. So when you draw the dotted line, you can either do it this way, like this. That's one way. Or if you want, you can do what I just did. Okay, draw a straight line. Sorry, it's not straight. So erase some part of that. Okay, something like this. Then we also have the dotted line again. And as I said a few seconds ago, you can read this in two different ways. You can say 2x is greater than y, or you can say y is less than 2x. So how can you determine if it is greater or less than? Just like last question, I said that we look at this with respect to y. So in this case, if you look at y, then you can say that y is less than 2x. So since we have less than, so therefore we shade the region below the graph. All the way to infinity. Okay, this one keeps going on and on. Same thing down here. All right. So part B, choose a test point in the solution area to verify your graph. So basically, you just randomly pick a point here. Okay, so you can pick a point here, a point here, a point up here, doesn't matter. So I'm going to just pick a point, let's say 5 and 3. So 1, 2, 3, 4, 5, 1, 2, 3. So this point here, let's call that point a point 5 and 3. So if you look at this point right here, the random point that I picked, graphically this would satisfy the solution. Okay, satisfy the equation. And again, we want to verify this. Verify the math means you plug in the numbers. So let's use the point 5 and 3. So use point P5 and 3. So again, we can plug that in to our equation. So we plug in 5 for x and 3 for y. Alright, so what's our equation again? Go back up here. 10x minus 5y is supposed to be greater than 0. So 10x minus 5y is greater than 0. So plug in 5 for x. So 10 times 5 minus 5 times y. Y is 3. And right hand side is still 0. So left hand side, 5 times 10 gives you 50 minus 5 times 3 gives you 15. Right hand side is still 0. Left hand side 50 minus 15, that gives you 35. And right hand side is 0. So it says 35 is greater than 0. Of course, this is a truthful statement. So that means the point is a solution to the graph as expected, because we did that graphically. Part C, test a point on the boundary line. Some of you probably realize that I've never quotation mark randomly pick a point along the line. So let's see what happens, because any point on the line is a little bit iffy. So anyway, you'll see this in a second. So pick a test point on the boundary line. So if you look at this, obviously there's a point here. So let's pick this point here. Let's call that Q. And I like 0, 0 here because it is easy to do. So this is a point on the line. Okay. So let's pick the point. Pick point Q. You don't even have to call that a point Q or P or A or something. So pick a point, in this case 0, 0. So now once again we are going to plug this into the original equation, or sorry, inequality, which is 10x minus 5y greater than 0. So 10x minus 5y is greater than 0. So plug in, well, this one's easy, but I'll still do it for you. So substitute 0 for x and 0 for y. So 10 times 0 minus 5 times 0 on the left. Right hand side is greater than 0. And then 10 times 0 gives you 0 minus 5 times 0 gives you 0 greater than 0. Left hand side 0 minus 0 is of course 0. Right hand side is 0. Now when you look at this, hope you can see that 0 is not greater than 0. So what can we say now? Therefore, the point Q 0, 0 does not satisfy the inequality Okay, so if I were you in the future, when it comes to verifying something or testing if something is a solution or satisfy something, I would definitely not pick a point on the boundary line. Nothing here. Okay, either something here or something here. Alright? Alright, so second last question, we're almost there. Write the inequality for the following graph. So the first thing that should come to your mind is inequality. So that means you either have greater than or equal to, or greater than, less than or equal to, or less than. Okay, definitely not the equal sign. Second thing is when you look at this graph here, this line, the boundary line or a line, it is linear. Okay, so if you don't know what that means, you can look at your formula sheet. So for a linear equation, we may want to take advantage of this, the slope-intercept form. So y equals to mx plus b. So that means if we can somehow magically figure out m and b, the slope, and then also the y-intercept, then we can figure out this. Okay, so if you look at this, well, I hope this is obvious enough that this is the y-intercept, so that means your b is -2, b is -2, and then the only thing left to find out is m. If you don't know what m is, or that's the slope, or if you don't know the formula, so this is the complicated version. So basically here we can say equals to rise over run. So now pick a point, actually pick 2 points. From the 2 points you can figure out the rise and the run. So to find the slope, which is m, which is rise over run. So I don't know what your Math 10C or junior high math teacher taught you regarding finding a slope on a graph. But anyway, so I'll still show you Cheng's way. I'm going to look at this point. This point here, and this point here. Alright, so if you look at this, if you move the x value to more positive, so that means going from here to here is getting more positive. So this is what you would figure out, that and that. You have increasing value of x. Okay, to go from this point to this point. Well, why did I pick these 2 points? Well, of course they are sitting at the corner, so that's easy for me to see. If you want, you can pick these 2 points. They are also good. These 2 points are also good. Okay, so if you look at this, going from here when x is 0, here when x is 1, the graph moves 1 unit to the right. Going from here, y value is -2, y value is -4, so that means the y value decreases by 2 units, so -2 here. Okay, some of you may say, Cheng, can I do it this way, going here like this and then here like that? Absolutely. So as you can see, the graph goes down by 1 to 2 units, down by 2, -2, and then it goes from here when x is 0 to x is positive 1, so that means it's also increased by 1 unit in the x values. So either way, okay, so let's erase this to avoid confusion. Now if you look at the numbers we just figured out, so your rise is -2, and then your run is 1. So plug that in, that gives you a slope of -2. Now I know B, I know M, so plug in B here, plug in M here. So that means my equation is y equals -2x minus 2. Alright, are we done? We are not done yet. Why? If you look at this, the question is asking the inequality. So this is not inequality. Now the question is, which inequality sign do we replace the equal sign here? So you may want to pause a few seconds and think about that. Alright, so if you look at this here, this is a solid line. What does that mean? We have an equal sign or equal component. So therefore, this cannot be the case. This cannot be the case. Okay, now it's just a matter of either this greater than or equal to or less than or equal to. So now if you look at this graph, this section is above the graph. This is below. So above, that means greater than or equal to. So our only option is greater than or equal to. So that's the answer. Okay, the last question, your favorite word problem. So have a look. So blah 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 blah. Make a graph that shows all the possible combinations of tiles and stone if you have a budget of $150. So we need to know what the equation looks like first before we can make a graph, of course. So in this case, as you can see, the tile costs $2.50 per square feet, and then the stone costs $6 per kilogram. And you just need to find, if you have a budget of $150, how many tiles and stone combinations can you have? You may spend all the money on tiles only, or you may spend all the money on stones only, or you may split that up, spend some money on tiles and then the rest on stone. Okay, so do we know how much money we should be spending on tiles? Nope. Do we know how much money we should be spending on stone? Nope. We know that the total cost for tiles and stone, whatever amount we have, would add up to a total of $150 max. Alright? So since we don't know how much tiles we should be using and how much stone we should be using for the mosaic, so we may want to make some assumption using the unknown x and y. So let x be the square feet of square feet of tile used in the mosaic. And then you can say the same thing. Let y be the kilograms of stone used in the mosaic. Alright, so take a few seconds, think about how you can use the information given in the question and then the unknown x and y to help us set up the question. Alright, so let's do this. Do we know how many square feet of tiles we want to use? No, we don't. So just call that x. And for x, the tiles is $2.50. So put down 2.5. If you want 2.50, it's fine. And then for, do you know how much stone should we be using? No, we don't. So stone is for y. Okay, and we know that stone is $6 per kilogram. So 6, and we want a budget, so that means adding these two up of $150. Okay, so this is wrong. What's wrong? Because can we spend less than $150 on the tiles and stone? Absolutely. So erase this. We can spend up to $150. Less than $150, that's fine, or up to, which is equal to $150, so which is also fine as well. Now we have the equation. Of course we can graph it, but before we graph it, once again have a look. So we want y, we cannot have 6y here, so minus 2.5x minus 2.5x, so cancel out. So that means 6y. This time I'm not going to change this to the equal sign. You all should be getting used to that. Okay, less than or equal to 150 minus 2.5x. Sorry, I don't know what happens to my stylus pen here. Okay, so like that. And then divide both sides by 6. So 6 and 6 cancel out. That gives you y equals to or less than. So you can take 150 divided by 6. That gives you 25, and then minus, so take 2.5x divided by 6. So 2.5x divided by 6. I know it looks a bit weird, so let's rewrite that. Y is less than or equal to 25 minus, so multiply the top and the bottom by 2 so that you can get integers. So multiply the top by 2, that gives you 5, and then multiply the bottom by 2, that gives you 12. So that's, your calculator is smart enough that if you plug this into your graphing calculator, it will still work. Okay, so graph. What's wrong with our graph? There's nothing wrong, except you may have to change the window because the numbers that we are getting for the graph, they are kind of large, so change to something larger. Okay, so change the window setting to this. We should be able to get something. Nope, not good enough, so let's change the x values. So let's do 70 graph. Now here we go. So you might want to use the special features on your graphing calculator to find the x-intercept and y-intercept. So do it now. Okay, so let's graph that. If you look at this, what's on the x-axis? The tile stuff. What's on the y-axis? The stone stuff. So let's graph this. Square feet of tiles, and then y-axis we have the mass, kilograms of stone. Our graph looks like this. A straight line. Okay, then if you look at your graphing calculator, we can quickly look for the y-intercept. So 3, 0, enter. So 0 and 25. So here it is 0 and 25. Let's quickly find the x-intercept. So second trace, number 2, left bound, yes. Okay, enter it again, and that gives you 60 and 0. So that means it is 60 and 0. Now look at our graph. Y, first thing first, we have less than or equal to, because we have the equal component here, so it should be a straight line. Sorry, a solid line, not dotted one. And because of less than, so therefore we would have the graph. The solution area is actually below the line. This is below. The other side is above or greater than. Okay, so let's look at the extreme cases. So here, that means you can have 60 square feet of tiles and then no stone. This one here means no tiles and 25 kilograms of stone. Somewhere in between would be a mix, depending on which one you look at. All right, so last thing, textbook questions that you can try and enjoy.